The sun is what gives us life and supports us, but it also poses dangers. It is governed by a strong, unknown, hidden force, the magnetic field.
Despite shining down on the Earth for millennia, there's still a lot we don't know about the sun. One of the biggest questions scientists are investigating now is how our host star's magnetic field affects its regular cycle of activity. It's called the solar cycle. The solar cycle is the roughly 11-year period of fluctuating activity of the sun's magnetic field. And over those 11 years, the sun's poles completely flip, meaning the North Pole becomes the South and the South the North. This cycle can be visibly measured by an increase and decrease of sunspots on its surface. The least sunspots in an 11-year period is considered solar minimum, while the most sunspots signifies the solar maximum. No two solar cycles are the same, and often vary in activity.
What are sunspots, and why are they dark?
Sunspots appear as dark spots on the solar surface because they're cooler than the rest of the sun, at 6,500 degrees Fahrenheit. Cooler doesn't sound like more active, right?
That's actually a pocket of very, very intense magnetic field.
The reason the temperature goes down is because the magnetic fields in those areas are so strong that they create a barrier, stopping heat from the sun from reaching the surface. Solar maximum also results in increased activity in the sun's atmosphere, known as the corona. That activity creates bright and active regions that are rooted in the sunspots below, and are the origin of solar flares or coronal mass ejections.
A super flare.
Okay, so it's not like a Nick Cage disaster movie, but solar maximum can have consequences in space and on Earth. The sun impacts space weather, which can disrupt satellites, GPS, and telecommunication systems, and it can endanger our infrastructure too, including the power grid. Plus, radiation from the sun can be dangerous for astronauts working outside the ISS. If we could better predict the timing and intensity of the solar cycle, more measures could be taken to protect from the sun. But increased solar activity can also create splendor for us here on the pale blue dot. Particles ejected from the sun interact with the gases in our atmosphere. That intermingling results in the northern and southern lights, a beautiful display of colors close to the Earth's poles. So, what causes the solar cycle? Well, we still don't know. But NASA and the European Space Agency are on the case, sending probes closer than ever and from new angles, in hopes of filling in as many questions about the sun as they can.